Good morning, everyone. This project is about sentiment analysis on YouTube comments. The objective of this internship project is to perform entity level sentiment analysis on YouTube comments using provided training and validation data sets. As you can see, these are the training data set in the left and validation data set in the right. I have done some data preprocessing. In data preprocessing, it means removing the duplicate rows, loading the training data, handling missing values, and dropping rows with missing values. I have cleaned the data, like removing the special characters, URLs, and say emojis. Display the first few rows and print the preprocessed data. As you can see, this is the output for the training data set in the left and the validation data set in the right. Now I have done some model development. I will be using TF-IDF factorizer. TF-IDF factorizer, we have to convert the textual data into numerical features to carry forward. And I have initialized TF-IDF factorizer with maximum of 5,000 features. After converting it into TF-IDF matrix, as you can see, the training data consists of 1,000, 5,000. The output that indicates TF-IDF matrix consists of 1,000, 5,000 means there are a lot of samples, but we are taking 1,000 sample in each data set and TF-IDF factorizer with 5,000 features. Next, I am going to build two models, that is TF-IDF factorizer with ML algorithm, and I will be using LSTM with TensorFlow API. As you can see, in TF-IDF factorizer approach, these numerical vectors represent the features of textual data. And we traditionally use machine learning algorithms like logistic regression, random forest, or support vector classified to train classifier using numerical features. And this is the LSTM with TensorFlow Keras API. In LSTM, networks are a type of recruit neural networks, RNN, architecture designed to work well with sequential data. And this is the output after I used a model deployment, which is I used epochs, 10 epochs to see I got the classification accuracy as 0.266. And this is the performance difference between the two. The model deployment with the TF-IDF factorizer, I got it as 91.2%. And the model classification accuracy for LSTM was 27.7. So it is low accuracy. So I will be going with model deployment with development with TF-IDF factorizer only. Next, this is the sentiment class distribution for training data. And this was the obtained sentiment distribution for validation data. This code was in the code which I shared in the source code. And this is the visualization dashboard sentiment distribution for each entity. As you can see, this is the graph for each entity. And this is the visual comparison between sentiment analysis methods. As I said before, TF-IDF factorizer, I used logistic regression. We got 91.1 accuracy. This is the graph. And for LSTM, as I said, it was nearly 26.6, which was the graph. So in comparison, TF-IDF factorizer with logistic regression algorithm, this model is the best model for continuing moving forward. And I have plotted word plots for positive sentiment. I have plotted word plot for negative sentiment and neutral sentiments also. And irrelevant sentiment, I have plotted word plots for each and everything. You can check this graph. This is the visual distribution for the confusion matrix of the model which we have chosen. And the accuracy was 0.266 and precision was this. And this is the visual dashboard distribution of textual length of mean entity sentiment. As you can check here, this is the mean entity sentiment to mean sentiment. This is the visual dashboard distribution. And the recommendations which I got are based on analysis finding. The recommendations which I got is identifying popular topics or themes that generate positive sentiment and creating more content around them, and addressing common issues or concerning highlight in the negative sentiment comments to improve audience satisfaction, leveraging insights from sentiment analysis to tailor marketing strategies and promotional campaign effectively. You can read all these points, which will be very useful. Thank you.